Okay, making a breadboard. I'm really excited about this one. I have been looking for a really long time, really many years, on what's the best way to teach how a breadboard works. Because if you can use a breadboard, my gosh, these things are powerful when it comes to prototyping things and discovering things with electricity. Really excited about this one. You are going to need Tinkercad. So here's an example of a breadboard I have here. Might be able to zoom in without it killing my sound here. So this is a breadboard and it does really cool stuff. So yeah, so let's play with this and learn what a breadboard is. Okay, so first off, a breadboard, well, you want to be able to make an electrical connection either with some cool circuitry you're doing or just some lighting, or maybe you're just trying to develop a device to open or close a gate or do something cool. Breadboards are how you're going to do that. So let's look at the insides of the board here. So if you look, you have these rails on the outside, and this is the board that we're going to use here. So you have these long rails that are like columns on the outside. One is plus, one is minus. Then you have a divide, and then one is plus and one is minus. So each half of these breadboards are separate. So we're just going to look at this side. Okay. Everything in the plus is connected. So every little hole here is connected to the other little holes. And that's what you have here. So you have this long rail here, and all the holes, you can see all the holes are connected. So if you plug something in here, it's also connected to here. It's also touching or connected to here. The same thing is true with the black, except the black is not touching the red. And that's how these breadboards work. You have a whole bunch of divided sections all up. Well, you have, these are called the rails, these columns. You also have these rows, row 1 through 30 on this particular breadboard. Some are bigger, some are smaller. There's really a lot of variety here. But they all work like this. So each row is connected. So I put a whole bunch of kind of lines and wires in here to try to show you how they're connected. So in this row, 1A through 1E, these are all connected. So all of this green line, F through J, is connected. Now, the divide kind of marks this is one section, this is another, but this is how it works. So each of these individual rows are connected, but they're not touching each other, okay? And this is all connected straight up and down, and so is these two rails. That's the basics of how a breadboard works. But you really don't kind of get it until you play with it. So let's look down here. And so in your activity here, I have, you have columns, you have rows, and you have rails. So once again, the rows are connected. So row 1, 2, 3, 4, 5, 6, they're all individually. So everything in row 7 is connected. Everything in row 8 is connected, but row 8 is not connected to row 7. Okay, the rails are all connected, but the column of F, none of these are connected at all. This is how you make circuits work and do cool stuff. Okay, so here's an example of a breadboard. Now I've taken two AA batteries and I have wired them in here. So I've connected a wire from the positive end of the batteries to the positive rail. Okay, so now everything on this positive rail is receiving electricity. And I've connected the negative rail to the negative battery post. Now everything from the negative rail is now connected to the battery. So the electricity can come out of the battery and then go back into the battery. Because it goes in, actually, no, never mind, it can't. Why can't it? Because it's not connected. Just because the battery's connected to the rail doesn't mean this rail's connected to this rail. So I would have to have another wire connected between the two here if I want them to be connected. That's how it works. So hopefully we can figure this out. Okay, now let's say I want to light up this light bulb here. So what do? I want to create a circuit to light the light bulb up. So hopefully you'll see that the power comes out of the battery. Actually, technically power flows from negative to positive in electricity, but we're going to ignore that and just talk positive and negative here. So we have power connected to the positive rail. Now I'm tying in the positive rail to row 3. Now all of the remaining 4 holes here that I could put a wire in are energized, right? So there is electricity available in the rest of row 3. But I need to get electricity to the light bulb. So what do? I then take a wire and plug it into row 3, which is connected to the rail, which is connected to the power source. So this wire is going to go and connect to one of the terminals of the light bulb. Well, electricity has to loop, so it has to go in the light bulb, through the filament, and then down and out this wire. So I've attached this wire, and I've put it in row 6. Does it matter what row? Well, the only thing that really matters is I don't put it back into row 3, because that's where power is coming from. As long as it goes into a separate row, it does not matter where I put it. So I'm going to put it in row 6. But circuits require loops, and this is not a loop yet because it needs to go through the positive, through the light bulb, and then back to the negative. Okay, so let's go ahead and do that. I attach my last wire. Now look at this. It's in row 6, but it's not touching in the F column. It's in the J column. It doesn't matter, though, because this entire row, this entire row is connected. So now power can come from the positive through into the light bulb, through the filament, heat it up, let it glow, let it come back here, and then through row 6, out of row 6, and then into the negative rail, and the negative rail is all connected. It goes back to the battery. I've made a complete loop, and that is how the breadboard basically works. Let's look really quick at resistors here. So a resistor is something that's slowing down the flow of electricity. It's measured in ohms, and this little kind of squiggly line is the symbol for a resistor in a circuit schematic. And there's the bell. Okay, so this is a resistor. So let's talk about resistors. Well, first off, resistors have color codes, and these are actually really cool. To me, this is like a puzzle, and I can figure out a puzzle. So here are a bunch of different types of resistors. The bigger the resistor, the more power it can handle, and vice versa. Okay, but the amount of resistance, or the amount it slows down the electricity, is determined by the color bands here. Now you got to be careful, because it doesn't matter which way they're connected. This is not a one-way thing, so it doesn't really matter which end is first, which end is positive, which end is negative. So when you look at your resistor, you want to look for the gold band. It's usually gold, and that's the tolerance one here. So this is how we're going to interpret this, and you can see that the gold band actually looks gold. Okay, well, you have multiple bands or multiple stripes on your resistor. Your first band corresponds to the first number, second band, second number. So, and then we take those two individual numbers and multiply them. So if you wanted a 440 ohm, I would need yellow for 4, and then yellow for 40. But instead of it being 44, see, if it was 44, it'd be yellow, yellow, black. If I want 400, right, or the next, just if 44, yeah. No, if it'd be, my gosh, my brain, it would be 4.4 if it was 1. It would be 44, 10, 440, 100, 4,000, 400, 1,000, and then, 44,000, right? So that's how this works. You use the multiplier, and if I can get my brain not to mess up, that would be awesome. And the band, the last thing on the band is tolerance here, and that is, so if I'd said 4,400 or 440, it'd be 440 plus or minus 5%. Because nothing is ever perfect, and that's how we figure out. So plus or minus 5%. I've honestly never seen a resistor that's less than 5, as in the 10 or 20%, but I guess it's possible because they put them on all the charts. So that's how this works. Here's a nice little example for you. So if you wanted to do 68 kilo ohms, you would do a 6 blue, an 8 gray, and I would need it kilo, so that make that 1,000, so that'd be kind of orangey color. So you'd have blue, gray, orange, and a tolerance of 5. So blue, gray, orange, gold. Or if you flipped it around, it would be gold, orange, gray, blue. So it's kind of a puzzle, and it's kind of fun. So I have some of these for you guys. I want you to do, I'm giving you an example. 330 ohms at 5% is orange, orange, brown, gold. I want you to do 330 kiloohms, which is what? I don't know. I need you to figure it out for me. And I need you to then look at the color stripes and then figure out what the number is, and so on. So go ahead and fill in the rest of this chart. That would be kind of awesome. In fact, what I'm going to do here is I'm going to, I think, highlight. Oh well, I'll mess with it later. Okay, that's that. Okay, we want to add an LED as well here. So an LED now is this really cool symbol, and this is the symbol for a one-way valve LED. It's a light emitting diode. All diodes are one-way valves, but this is a light emitting diode, which is kind of cool. So if you want to know how an LED works, you just click on this link here and it'll take you to how does an LED work on like really kind of a cool level. So that's that video there. I'd recommend watch it. It's just a minute or two. So what is an LED? They kind of look like this. And notice that they're not connected on the inside because light is literally jumping across, which is really cool. And how fast it jumps is the wavelength you get of the light, or basically how fast it jumps determines light color. Okay, so this is the symbol in a schematic. This is what it looks like in real life. You have a flat edge. The flat edge has a short lead, and that's negative. The round edge is positive, and it has the long lead. Okay, so just kind of an idea of how what are these LEDs, and it's very simple about how they work, but I'm not going to get into it too much. The biggest thing I'm going to say is that it's a light emitting diode. It's a one-way valve. It will not work in backwards. It's polarity sensitive. Positive has to line up with positive, and negative has to line up with negative, or it will not work. So if you set up everything perfectly and it's not working, flip that LED around backwards, and it probably will work because you probably have the LED in backwards. Easy mistake. Everyone does it a ton of times. Okay, building a circuit on your breadboard. So we have a schematic, we have a breadboard, and we want to kind of combine the two and make this work. So how do I do that? Well, I'm going to need a power supply, I'm going to need a 330 ohm resistor, and I'm going to need an LED. Remember that all LEDs must have a resistor or they explode, and that's bad. Okay, so I'm going to start with a breadboard and a power supply. And then I'm going to attach the power supply to the rails like we did in the first example. In fact, I think I just stole this from the first picture. Okay, so 3 volts of power. How do I know it's 3 volts? These two batteries are in series. 1.5 plus 1.5 is 3. And that only works when it's in series, but that works for battery packs in general. Oops, let's fix that. Okay, so now what's next in the section? So I've attached it to power. Now I need to add a resistor. So if you look in Tinkercad, you have the menu here, and you can just look up resistor, or it's right over there in basic components. Pull a resistor over, and I love it. The color codes match with whatever you do. So pull down the little drop menu and make sure it's in ohms and not kiloohms or picoohms or microohms or gigaohms or whatever it is. We usually are just going to deal with ohms and kiloohms, but make sure it's the right unit, right number, and then you get the right colors, which is orange, brown, gold. Look it up. It's going to be awesome. Now in this case, I've just taken the resistor and I've attached it to the rail, and I'm actually using the resistor to tie into row 7 here. Okay, so I'm going to have power from positive to the resistor into that rail. Okay, now I've got my resistor set up. Now I need to add an LED. So let's go to the next section. Remember, LEDs, they only go one way. Okay. So, and I also need to have, I only have row 7 has power. So how do I add this LED? Well, I need to add the one end of the LED that's positive into the same row that the power is coming in. So I've done that. I've put that there. And you might need to rotate your LED around in Tinkercad just so you can see what you're doing. Remember, rotate is the R key. Okay, so now I've got my LED in there. Yay, my LED's there, but it's not done. I need to add this wire that goes back to the power supply. So I'm going to come over here and tag a wire. Now remember that I want the power to continue a loop, so it's got to come out. Power's going into the rail, into the resistor, into the LED, into the row, and now it's going into the negative rail and back to the back. All right, the last section of this activity, you're just proving to me that you know how to do stuff. So you're not only proving to me that you understand how you use Tinkercad to use breadboards, you're also proving to me that you understand how these circuit schematics work. So you're going to read this pirated circuit schematic that I stole and redrew horribly, but still stole and redrew. And you have a lamp, you have a resistor, and an LED, and this is a series circuit. So remember, the series circuit it's just one loop. And I want you to go into Tinkercad and make this for me. Okay, so everyone's circuit's going to look a little bit different, so that's cool, but it'll all have the same components. Now when you get down here, I want you to insert a picture of your Tinkercad circuit and include the name of your file in your picture. So it's not technically your name, but if you go to Tinkercad, this one's the Incredible Snagit Firan or whatever that is. So when you do your screenshot, include that picture in your screenshot. Okay, so this is this is a similar picture of what we're talking about here. But so it shouldn't look like mine, and it shouldn't have my name on it. But include your name so I know it's legit you. Okay, and then go to the parallel circuit. Now this is the same components, except it's set up where the lamps are in parallel. Okay, so how do you do that? Well, instead of having one continuous loop, the circuit comes after the resistor and then spreads from the resistor to one track to another track, and that makes it in parallel. Give it a try, and we'll check it together. Once again, include your name on there. And that is this assignment. I am not crazy frustrated now. I don't care if it's perfect. I want you guys to progress. That's what I'm trying to get at. And with that, I will chat with you next time.